What's up, you guys? Mr. Pike coming to you live from, I'm actually in Marcus right now, but you can't tell where I am. I'm hiding. All right, so in this unit, we're going to be talking about radicals. Radicals are square roots. That's all that means. It means cube roots, quartic roots, any root. So that's all that radical means. So that's we're going to kind of see the properties of that. So with these, starting with the basics, determining the products. Remember, that's just multiplication. If we have radicals, square roots, they multiply the inside to inside and outside to outside. So if we had like a 2 and a 3, the outsides would multiply and the insides would multiply. In this case, we just have insides. So 7 times 5 is 35. I keep it under the same square root. From there, I would see if it simplifies, but in this case, it doesn't. So that's my solution. All right, square root of 6 times 21. So I will multiply these, so that would become 6 times 21 is 120 plus 6, so 126. So now with square roots, don't forget that we can simplify these. So I need to think about what's the biggest square that can come out of both of these. So let's see. I think it's going to be 3, so 9. So 9 divided by there, this would be 9, square root of 9, times the square root of, let's see, 14, I believe. Yes, 14. So we know the square root of 9. The square root of 9 is 3. I don't know the root of 14, so I would leave this 3 root 14. That would be my solution. Sometimes it's easier to think about these before you actually multiply. So like this one, this is 2 times 7. This is 2 times 5, right? All square roots still. If I kind of break it up, so I know the square root of 2 times the square root of 2 is going to combine, right? That times that is just going to make the square root of 4, which is 2. And then I'll have 7 times 5, which is root 35. If you didn't see this right away, you could also do the square root of 140, but 140 is 4 times 35. The biggest square we can take out is 4, so that will reduce to 2 root 35 as well. All right, moving on. With part D here, we have 3 square roots multiplied by each other. But again, what I would like to do is make this the square root of 2 times the square root of 5, which is what square root 10 is, because now I see that I have 2 root 5s, and I can pull that out as 5. Square root 3 times 2 is 6, so 5 root 6. Again, we have 3 square roots. So here, this one will actually simplify as root 4 times root 2. So notice, I know what the square root of 4 is. The square root of 4 is 2. So I have 2. And then I also know square root of 2 times square root of 2 is going to make 2. So I have 2 times 2. And then I'm left with that root 5. He's all alone, so I'll leave it 2 times 2 root 5, which would give us 4 root 5. Oh yeah. All right, right, 2 radical expressions that are equivalent. So one thing that we could do is I could make this, if I'm putting it back in, I can make this the square root of 49 times the square root of 3. Square root of 49, well, that is one expression. So the square root of 49 times 3 would be the same thing as the square root of 147, which is also an equivalent expression. For part B here, 6 is the same thing as square root of 36. And then I have square root 2. So that would give me the square root of 72 altogether. That's also equivalent. So they may be pulling that on Apex. All right, for example 3 here, what are the square roots of the following? So here, there are 2 types of square roots that we could be using. One is just like the regular square root. Another is called the principal square root. So the regular square root is just like 8 or negative 8. So if I were to square root 60 or square either of these numbers, 8 squared is 64, just like negative 8 squared is 64. Sometimes this is written as the absolute value of 8, because either way you go from 8, it will represent 64. So this could be plus or minus 6 or absolute value of 6, either way. The principal square root is just the positive. So the square root of 64 is just positive 8 for the principal square root. Square root of 36 is just positive 6. It does not include the negatives there. All right, moving on. So we have determined the quotient of the expression. So notice I have division here. So what can happen is that since I have the square root of something divided by the square root of something else, it's the same thing as saying the square root of those two things divided by each other. So I do 76 divided by 2 is 38. And then I would see if that simplifies, but that's 2 times 19. 19 and 2 are both prime numbers, so that's as far as I can go. I'll just leave that root 38. Moving on, 24 over 2 would give us the square root of 12, which is square root of 4 times the square root of 3. So that is 2 root 3. And root 128 over 2 would be the square root of 64. Square root of 64 is perfect, so that's just 8. Now this one's a little bit tricky. So what would help probably would to make this the square root of 4 times 2. So this is the same thing as root 28 over root 8. 28 over 8, let's see, divides to 14 over 4, 7 over 2. So square root of 7 over 2. All right, so now what they're going to do is they're going to do something called rationalizing the denominator. You'll see a lot more about this later on, but this is the same thing as root 7 over root 2. So what they're going to do is they're going to multiply our equation by the bottom denominator, because now what this creates is the square root of 4. We know the square root of 4 is 2, so this is 2 in the denominator now, and if I multiply these two things together, that becomes root 14. You could have also seen it from the beginning, and we would just leave this 2 in the denominator, divide the square roots, and that would give us root 14 over 2. Either way you want to see that, but I did want to talk to you real quick about rationalizing the denominator. So again, notice that this is just 1. It's just a really weird looking 1, because it's root 2 over root 2. But when I multiply it by the same square root of itself, it gives me a perfect square, which will make the denominator a perfect number, or not a perfect number, a whole number. No more square roots. So it's just 2. So the reason that exists is we're dividing root 7 by root 2. So this is like 2.646 or something like that. I can't remember. Divided by 1.414. It's much easier to do root 14 divided by 2 because that's a decimal number divided by just 2. All right, moving on. Like I said, you'll see rationalizing the denominator much later. So here, multiplying straight across, that gives me root 15 over 2. That's our answer. Can't simplify it anymore. All right, one more. So I have root 3 times root 3 is root 9 over root 20. So that will give me 3 over root 20, which is also 2 root 5, right? Because that's 2 root 5. So I'll rationalize the denominator again here. So what I'm going to do is I'm going to multiply by root 5 over root 5. Notice I picked this square root such that when I multiply these things, I'll get 3 root 5 over 2 root 25. I know the square root of 25 is 5, so this becomes 3 root 5 over 2 times 5, which is 3 root 5 over 10. That's how I would write my answer. All right, super short, super fast. Please, 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 you guys are going through this. Let me know what questions I can answer for you, though. Look forward to hearing from you. All right, I'll talk to you soon. Bye. Maybe if it would pause. You wouldn't have seen that, though, if we paused. All right, bye.